Y'all ready for math? Y'all ready for start? How we doing there, folks? Okay, another pre-calculus honors video here. I believe this is Wednesday's video. And just continuing with optimization problems. You could write optimization problems continued if you want to. Remember, we have two techniques to do these problems, okay? A calculator solution or a calculus solution. And really the main thing that people have to focus on is what work do they have to show? And also, how do they deal with the algebra and the geometry that's not calculus? So your homework problems, okay, from your dittos, calculator solution right here, the dimensions of a rectangular box of greatest volume, that was maximized volume right there. That can be constructed from 200 square inches of cardboard. Square inches, that's a measurement of area. An area for a three-dimensional object is always going to be surface area. If the base is to be 3 times as long as it is wide, then that's your little restriction right there. And Mr. Matina telling us the box as the top and the bottom. So here's our box right here, okay? I didn't know what the dimensions were. Try to stay away from X and Y, especially with the calculator. You know, I called this B. How'd I get 3B here? Well, they said that the base is to be 3 times as long as it is wide, okay? So if the width is B, that means the length has to be 3 times B, and then you have that other height right there, that dimension that they didn't really tell us much about. And look, it's not the easiest type of thing to set up in the world, but it's something that you're able to do, okay? And as far as volume is concerned, we know it's length times width times height, so B times 3B times H, that's 3B squared H, but we got to get it down to one variable, okay? And the surface area, if you get the area of the front face, it's B times H, which is BH, but there's 2 of them, okay? So that's the 2BH that's right here. If you get the bottom faces area, that's B times 3B, which is 3B squared, but it's also up here in the top, so that's why it's 2 times 3B squared. We didn't have that 2 yesterday because it was an open top. This is not open topped. You got to wrap it. And then the right face over here has an area of 3B times H, that's 3BH, but there are 2 of them. That's this piece, okay? So not the easiest thing in the world, okay? And let's put a little 200 right there for the surface area. Then you got to solve for B or solve for H. Probably easier to solve for H here. I know it's filthy, but that's why we're using the calculator. Imagine you had to take the derivative of something like this. It gets really annoying. You distribute, but then, excuse me, you'd be stuck with quotient rule. Okay, so something you want to try to avoid. They just don't ask about those types of things anymore. I need to see that, right? The equation in terms of one variable for what you want to maximize and minimize. Got to see a domain. It's got to be in terms of B because I only see B's over here. And if you just want to guess at the domain, say, well, I know B's got to be greater than 0. You're done, okay? That's the correct domain. B can't equal 0 because H would be non-existent. H can't equal 0 because there's no value of B that's going to make the numerator equal to 0. I guess you could try that. You might get values there. They're going to be irrational. Something's going to be wrong with that anyway. Not something I'm going to worry about. My kids are screaming and yelling upstairs because my wife left the door open. I'm going to go close that door. Okay, I'm back. All right, so anyway, they're screaming and yelling. Hopefully somebody's not hurt too badly. So here I got my domain. Let's actually, look at the graph right here in our calculator. You didn't have an upper element, so hopefully you played around with it a little bit. Make sure you show me that sketch. Make sure you label the axes. And make sure you label the maximum or the minimum point, and make sure you answer the problem, okay? They actually want to know the dimensions. Well, I know this is B right here, so the dimensions are going to be by 3B by H. People are like, where are these values coming from? You might have 9.999. That's fine. It's a truncated version of 10, but really B is 3 1/3. Multiply that by 3. That's where you get the 10 from, and then you get the H by plugging in right over here. So it's not as bad as you might think. It is a little bit of a filthy problem. Don't get me wrong. 4 should have been kind of cool. Calculus solution, not geometric, right? Find 2 positive numbers whose sum is 50 and whose product is as large as possible. We didn't do one like this. You might have been like, what the heck is this nonsense? Well, product as large as possible. We want to maximize the product. We don't know what the 2 numbers are, so I let A and B equal the numbers. Product is going to be A times B. Make sure you set something equal to it. And then we got to get it down to one variable. They told you the sum was 50. A plus B is equal to 50. Solve for A or solve for B. It's up to you. I solve for B. And here we got an equation for what I want to maximize and minimize. I got an equation for that thing in one variable. And the domain, you want A to be greater than 0, not because it's a geometric situation, because A is a positive number. 0 is not positive, a negative is not positive, A's got to be greater than 0, which means B, if you said B equal to 0 over here, you'll get A equal to 50, so A's got to be less than 50 in order for B to be greater than 0. That's really what's going on there. Don't graph it. This guy's Y values represent products to find, you know, the maximum. I mean, surely there must be some sort of test, and there is. The first derivative test. Take that derivative. I got to see it. It's existing everywhere. It's a linear. Set equal to 0. I got to see it. Okay, and then solve, okay? No units here because that's just one of the numbers. Draw that line, okay, A prime line in this case. Show me that there's a maximum. Write the blurb. I know there's a max product when A is equal to 25. Then answer the question. They want to know the two numbers. Well, if A is 25 is one of the numbers, that means B equal to 25 has to be the other number. So make sure that you actually answer the question. A couple more problems like that in tonight's homework. Hopefully it's not as bad as you might think. It really isn't, okay? You know, like I said, if you have questions, send me a remind, send me an email. We'll talk about it that way. I've had feedback from people. A lot of people tell me the videos are easy to understand, okay? If that's not true, give me some feedback, okay? Look, I'm very selfish with my food as well. I don't like to give feedback to people, but, you know, it could be nice to help out planning these lessons. There's another ditto I think you downloaded. Might be called like 2.3, some other problems or something like that. So we still have that 2.1 optimization packet that we're going to be using. But you also want to be looking at this ditto as well. And let's take a look at number 1 on this ditto, very popular type of problem. And we're going to go for a calculus solution here. So calculators, what? You're not going to use me? What are you doing? I can't. Let's put him over there. He just never stops talking. He's like, you know, some of you guys in class. Anyway, so a rectangle has its base. That's base on the x-axis, and its upper two vertices on the parabola y equals 12 minus x squared. You're like, what the heck is going on here? What is the largest area the rectangle can have? Oh, the largest area the rectangle can have. I want to maximize area. I want to maximize area. Don't give me no disparitor. So that means we got to get an equation for that thing. You might be like, what the heck is going on here? Well, they have this parabola. You're supposed to be able to do this without a calculator. Y equals 12 minus x squared is really y equals negative x squared plus 12. And y equals negative x squared, we know is y equals x squared reflected in the x-axis. It looks like this. But then we're going to shift it up 12 units. Okay, so it's going to look a little something like this. You should have that ability. Here's y equals 12 minus x squared. And now we got a rectangle, has its base on the x-axis and its upper two vertices in the parabola right here. So the base is going to be here, and a vertice might be right here, okay? And that would mean the other vertice is going to be here. What would the rectangle look like? A little something like this. But they don't all need to look that way, okay? You know, if you actually have this situation, I'll diagram it over here. You know, it all really depends on where the point is, okay? This point right here, we don't know the coordinates of this point, okay? It's some point on the parabola, some arbitrary point. I'll call it P for point. I'll say his coordinates are x comma y. You got to move to the right x. You got to move up y. Depending on where that point is, that point could be down here. And if it is, it's going to have a counterpoint on the other side. And now the rectangle would look something like this. It'd be short and squat, kind of like Mr. Berto right there, okay? But the rectangle, if you actually, you know, put the dot up here, you know, the point could be anywhere, okay? You'll have another counterpoint over here. And then you can see you have a tall and thin rectangle, okay? Like some of you guys, you know, I'm short and squat. Some of you guys are tall and thin. Good for you. Anyway, there's an infinite amount of rectangles that could be here. So I just kind of draw one like this. And you got to get an equation for that thing. And to get the equation for the area of a rectangle, that's base times height. So people want to say this is B and this is H. Even worse, some people want to say this is X. And that's a major issue. The washing machine's making a lot of noise. That's a major issue because this is not X. What you have to understand is when you're on the X and Y coordinate plane, they've already identified variables for you, okay? If this is some arbitrary point, x comma y, remember, you move to the right x, and then you move up y to get to that point, right? If this is the point 3 comma 5, this distance would be 3. This distance would be 5, okay? But it's x comma y. This distance is x. This distance is y, which means the base of this rectangle is not x. It's x plus x, which is 2x. And the height we know is going to be equal to y. So with these types of situations, and you'll see this again, whenever you have a rectangle inscribed inside a parabola this way, the area is always going to be 2xy. too Xy. I'm too Xy for this class. Too Xy for this class. Anyway, so some people want to say, hey, this is B times H. That's fine, but at some point, you're going to have to say B is equal to 2X, and you have to say Y is equal to H. Why? Because to get it down to one variable, you need a relationship between the two variables. The only relationship they gave you was the relationship between X and Y. These problems are actually a lot easier because it straight up tells you that Y is equal to 12 minus X squared. You might be like, well, what does that mean? Well, this point right here, remember, a function always represents Y values. Very good. So instead of saying it's the point X comma Y, you could say it's the point X comma 12 minus X squared. So this distance right here is really 12 minus X squared. So you're really just doing base times height. That's all that's happening. Let's call this A of X, because in terms of one variable now, you can still just call it A. Nothing wrong with that. 24X minus what? 2X cubed. Got to get a domain, okay? In the domain, you could easily get the old ways by saying, hey, we want X to be, you know, it's got to be in terms of X greater than 0. Technically, X could be negative. Then you'll have this point that you'll be dealing with. It's a little bit easier to deal with things on the positive side. So let's just talk about X being positive. And it does have an upper element. If you want to actually take this 12 minus X squared, set it equal to 0, you get X squared equals 12, which means X is going to be equal to either radical 12 or negative radical 12, but we want it to be positive radical 12 in this case because we're dealing with positive X values right here. And we also want to think about X as a distance. That's why it's tough to think about using this X, which is negative. It gets a little weird. You got to worry about directional negatives and stuff like that. Or you can just think about this point as he bobs from here to here. His smallest X coordinate he could have is 0. The biggest X coordinate he'd have is this one right here. That's the 0 of the function, and you set a function equal to 0 to get the 0, you'll get the radical 12 that way. So other ways to do it. Regardless, I got a function in terms of one variable that I want to maximize and minimize. I got a domain. His Y values represent areas. I'd love to graph him, but I don't have the graphing calculator. I got calculus here. How do you figure out where a function has a maximum using calculus? Well, surely there must be some sort of test. And there is. Okay, the first derivative test. Let's make a prime of X right here. Take our deriv. You can really start having fun. You don't have to call this the area function. You could call it Optimus if you want to. People are like, why would I say Optimus equals 24X minus 2X cubed? When you take the derivative of Optimus, you would get Optimus prime. Okay, so that's kind of cool. If you want to do silly stuff like that, you better know what you're doing, by the way. Okay, don't mess around unless you really know what you're doing. This becomes what? 24 minus 6X squared. It's always existent. It's polynomial. Let's set it equal to Mr. Pushy's IQ. That would be 0. Okay, add 6x squared to both sides. Divide by 6. X squared is equal to 4. Have that collective sigh of relief where you're like, oh, x has to be equal to 2 or negative 2. But once again, we're treating x as a distance. This x coordinate right here would actually be negative 2. It's easier to deal with things on the positive side. Units, I need units, unless they don't give them to me, and they don't. So get out of here. All right, so we don't need to worry about units, but I'm showing you. That's why I draw the line. The A prime line, okay? Tis it bounded. It tis from 0 to radical 12. Hopefully you don't watch these videos while your parents are in the room. I don't want them to think you're being taught by a crazy person. All right, so let's put our 2 right here. Put all critical x values on the A prime line. That's a place where the area function would have a slope of 0. So A prime is equal to 0 there, as we know before. Let's plug into A prime, plug in a 1. 24 minus 6 times 1 squared, 24 minus 6 is positive. And then maybe plug in a 3. 24 minus 6 times 3 squared, that's 24 minus 6 times 9. 24 minus 54 is negative. And you can see we got that max there, but just some person reading this test doesn't know that. You got to explain this with a little blurb and say, hey, max area when x equals 2. And then you stop and you're like, what do they want? Oh, they actually want to know the largest area the rectangle can have. So you could take that x equals 2 and plug it into this area function right here in terms of x only. Or you can get what y is equal to. I like to do that. If x is equal to 2, y is equal to 12 minus 2 squared. So y is equal to 12 minus 4. So y is equal to 8. You know, why would I do that? Well, now I could use this area formula, 2xy, to get that max area. Max area. It's a cool thing to change your name to if you want to change your name. My name is Max Area. Mr. Area, how are you? Max area right here is going to be 2 times x times y. So 2 times 2 times 8, which gives us 4 times 8, which gives us 32. I get it. You could say like units squared or something like that, but it's not necessary, okay? They didn't give us units, so we don't give them units, okay? So another type of problem to see there, there's lots of different problems, so many different types. On the assessment, it will be a type that we have done before. I'm not going to give you something brand new, okay? Hopefully it won't be as bad as you might think. Anyway, I don't know when that's going to be coming out to you. Probably next week, in the beginning of the week, maybe by this Friday, but I don't know if we'll be able to get everything done by then. We'll see. Anyway, so that was optimization, I believe, 2.4. Okay, Wednesday's video. So, you know, another video right there. Like I said, if you're struggling with stuff, please get in contact with me. Just give me feedback, okay? I know things are tough out there, but do the best you can, okay? Stay healthy, stay safe. Miss you guys. And this is Berto, once again, signing out. See y'all later.